Okay, so we have these two functions, 2y squared and 4 plus y squared. Now remember the little trick that I showed you to graph a function with respect to y. If you forgot, go back to the mini lecture real quick and see my advice. But basically you graph it as if they're switched, and then you just rotate the axis. So this is, so here let me put x and y. Okay. So we have our two functions, and so let's find the intersection point. So 2y squared is equal to 4 plus y squared. So y squared is equal to 4, or y equals plus or minus 2. So here, these points right here are positive 2 and negative 2. Okay, now, then the third step is, so we set up our integral. We're going to go from negative 2 to 2. And then remember that to find the area, you're going to do, since it's a function with respect to y, you're going to do right minus left. So that means that you would have 4 plus y squared and then minus 2y squared dy. So that's our integral to find. So, all right. So let's do that. So we get, let's combine these two into, so y squared minus 2y squared, that's minus y squared. And so when I get the antiderivative, I get 4y, that's the antiderivative of 4, and then minus y cubed over 3, evaluated from negative 2 to 2. Okay, so then I get, plug it in, top minus bottom, all that kind of good stuff. I get 8 minus 2 cubed is 8 thirds, and then minus, plug in negative 2, I get 4 times negative 2, that's negative 8, and then plus negative 2 to the third, that's 8 thirds. And it's positive because you have negative 2 cubed is negative, and then times that negative is positive. Okay, so then you get, if I add the two, this 8 and, let me do this. So these two 8s, because of the negative, so that becomes 16. And then minus 8 thirds minus another 8 thirds is minus 16 thirds. And so this is equal to 32 thirds. Okay, so we have our two functions, absolute value of x right here and x squared minus 6. So we set up our equation, x squared minus 6 equals absolute value of x. But notice that, I mean, both of these functions are symmetric. So this value, these are going to be the same value. They're just going to have the opposite sign. So instead of doing x squared minus 6 equals absolute value of x, I'm just going to find one of those, this one, the positive one, and then I'll be able to find that one. So symmetry is going to help us a lot in solving this problem. So bring over the x, I get x squared minus x minus 6 equals to 0. And so then that gives me x minus 3, x plus 2 is equals to 0. So I get x is equal to 3 and negative 2. Now here there's a bit of a danger here, because notice you get two values, but these negative 2 and 3, that's not what these two values are. Because notice that you're letting x squared minus 6 equal to x. That's what you're solving. And the line y equals x really goes all the way down. You know, it goes straight here. So this value right here, negative 2, that's this value right here, but that's not part of your function. So this one you remove. The value that you're looking for is actually 3, and this one would be negative 3. Now, if you wanted to actually find negative 3, what you would do is you would set x squared minus 6 equal to negative x, because that's what this line right here is. But you don't have to, because it's symmetric. Now, if it was to the side of one, you know, then you would have to do that. But we can save that step here. Now, when we set up our integral, again, you know, so this is the area, but it's symmetric. So, you know, why go through the hassle of going, if you go from -3 to 3, you're going to have to do 2 integrals anyways, because you have to split up the integral for the absolute value. So it's much better to do half, just do this part, find this area right here, and then we can just multiply that by 2 for it to give us what we're looking for. So we're going to do the integral from 0 to 3 of top minus bottom. The top is absolute value of x, but in this part of it, this half, it's just equal to x, the function x, and then minus x squared minus 6 dx. So this is equal to the integral from 0 to 3 of x minus x squared plus 6 dx. Okay, let me get a little bit more room here. Okay, so this is equal to, I get x squared over 2 minus x cubed over 3 plus 6x. And this is evaluated from 0 to 3. Okay, so now plug everything in, right? So I get 3 squared, which is 9 over 2, minus 3 cubed, which is 27 over 3, that's the number 9, plus 3 times 6 is 18. And then minus just 0, because when I plug all that in, I just get 0. So then these two put together, that gives me positive 9, and then plus 9 halves, that's just 27 halves. And that's it. And that's just 27 halves. But then remember that we said that we're going to multiply that by 2. So the area is actually 27, because remember that we only did half, and then because of symmetry we just multiply that by 2 to get 27.